Current, electricity, 11th part. Conventional current. First, conventional current is from positive potential to negative potential. Then, conventional current is from higher potential to lower potential. Conventional current flows in the direction of flow of positive charge. Conventional current flows in opposite direction of negative charge. Then, definition of current or equation of current. Equation of current is charge transferred divided by time, or in derivative form it is dq divided by dt. If negative charges are flowing towards right hand side and positive charges are flowing towards left hand side, then current is produced due to negative charge as well as current is produced due to positive charge. So total current is what? Total current is addition of current due to positive charges plus current due to negative charges. If this is the situation, negative charges and positive charges are moving in same direction, then total current is equal to current due to positive charge plus current due to negative charge. Then electric charge carriers. Inside metals, which are charge carriers? Charge carriers are free electrons. Charge carriers are free electrons. Inside liquid, charge carriers are positive and negative ions. Inside gases, charge carriers are electrons and positive ions. And inside semiconductors, charge carriers are electrons and holes. Then, what are free electrons? Electrons which are free to move in the bulk of the material. Electrons which are free to move in the bulk of the material are called free electrons. Okay. Then what is thermal velocity? Velocity of free electron which is due to thermal energy. Velocity of free electrons which is due to what? Due to thermal energy. It's called thermal velocity. It is about 10 raised to how much? 10 raised to 5 meter per second. It is about 10 raised to 5 meter per second. And it has no direction. It is random. Drift velocity is about 10 raised to minus 4 meter per second. What is it? Bolo, what is it? 10 raised to minus 4 meter per second. Drift velocity is because of the potential difference. Drift velocity is because of the potential difference. Okay. Then types of current. There are two types of current: alternating current and direct current. In alternating current, direction of current changes periodically. In direct current, direction of current is always same. Okay. Then current due to translatory motion of charge. What is the formula? I is equal to N A E V D. I is equal to N A E V D. N is number of free electrons per meter cube. A is cross-sectional area of the conductor. E is charge on the electron. And Vd is drift velocity of the electron. Then if charge Q is rotating, then also it produces current. Then current produced is equal to Q into frequency. In velocity form it becomes QV upon 2 pi r. It becomes QV upon 2 pi r. V upon r can be written as omega. So Q omega upon 2 pi. And in terms of time period it becomes Q, and reciprocal of frequency is time period. Okay. What is N? N is frequency. What is the definition? Number of revolutions per unit time. What is it? Repeat what? number of revolutions per unit time. V is velocity of charge, r is radius of the charge. Omega is what? What is it? It is velocity. Which velocity? Angular velocity of charge. Repeat, what? Angular velocity of charge. And this is time period. What is the meaning of time period? Time period means time required to complete one revolution. Repeat, what? Time required to complete one revolution. Then Ohm's law. Ohm's law is V is proportional to I, V is equal to Ri. If we draw graph V versus I, then it is a straight line passing through the origin. Then slope of the graph is what? Slope of the graph is resistance. Okay. Then if earthing is done, then what is the potential of ground? Potential of ground is 0. Then positive terminal means what? Plus value or higher value? Positive terminal means higher value. Negative terminal means what? Minus value or lower value? It means lower value of potential. Then which are consumers of potential? Resistances, capacitors and inductors. And as long as conductor is present, potential remains same. As long as conductor is present, potential remains same. Then resistance is proportional to length of the conductor and inversely proportional to area of the conductor. So it becomes rho L upon A. Then if there are two resistances, first resistance is different and second resistance is different, and if we are comparing them, then R1 upon R2 is rho 1 upon rho 2 into L1 upon L2 into A2 upon A1. If second resistance is made from first resistance by stretching it, by keeping the volume of the material same, first resistance, second resistance, both have same material and their volumes are also same. Or we can also say that second is made from stretching of first. Then R1 upon R2 is L1 upon L2 square, or we can say A2 upon A1 square, or R2 upon R1 raised to 4. Okay. Then electric field inside conductor, its magnitude is potential difference divided by length of the conductor. Potential difference across the conductor divided by length of the conductor. Its direction is from, what is it? Higher potential to lower potential. Then its unit is volt per meter. Then it is of uniform type. Inside conductor, electric field is uniform. Then current density definition is current divided by area. What is it? Current, electric current per unit area. Its direction is same as electric field. And its unit is ampere per meter square. Then J can be written in terms of electric field and resistivity, like this, or electric field and conductivity. Conductivity is reciprocal of resistivity. Then drift velocity in the form of electric field. Vd bar is equal to minus what? E bar upon m into tau. Why minus sign has come to show opposite direction of Vd and direction of E are opposite. M is mass of electron, tau is relaxation time. What is relaxation time? Relaxation time is, what is it? Time between two consecutive collisions. What is it? Time between two consecutive collisions. It is mean free path divided by VRMS. Mean free path is what? Distance between two consecutive collisions. Then drift velocity in different forms. First form is I upon N A E. Then second, I upon A is J upon NE. J can be written as sigma E upon NE. Sigma can be written as E upon rho NE. And electric field can be written as V upon L, and rho NE as it is V upon rho L N E. Then dependency of drift velocity on area of the conductor. If situation is like this, if same conductor has different area at different sections, then VD is inversely proportional to area. And if there are two conductors, first one connected to same battery and second is also connected to same battery, their lengths are same, but they have different areas. Battery same, length same, material same. And if we have different areas for different conductors, then drift velocity in both of them is same. It is independent of area. Then what is this? This is mobility. It is mod of Vd divided by electric field. Then after that, carbon coding. Okay, so there are few tricks to remember it. First one is B, Roy, Great Britain, very good wife. There is confusion in B's. B. Which one is black, which one is blue, and which one is brown? So in B's, blackness decreases in downward direction. So this is black. Blackness decreases in downward direction. This is brown, and this is blue. And there is one more confusion between G's. This G and this G. Which one is gray and which one is green? In this, blackness increases in downward direction. This is green and this is gray. So start from 0, 1, 2, rest you know. Then for tolerance, there are three colors: golden, silver and no color. No color means 20% tolerance, silver color means 10% tolerance, and golden color means 5% tolerance. If color is costly, then tolerance is less. If color is costly, then tolerance is less. Then temperature dependence of resistance. Resistance at temperature T is equal to resistance at 0 degree Celsius plus 1 plus alpha T. T is temperature in degree Celsius. Alpha is temperature coefficient of resistance. Same relation is there for resistivity. Resistivity at temperature T is equal to resistivity at 0 degree Celsius into 1 plus alpha T. What is resistivity? Rho is m upon n e square tau. Tau is relaxation time, m is mass of the electron, e is charge of the electron, as n is number of free electrons per meter cube. Then different materials are used for different purpose depending upon their resistivity. So standard resistances in lab are made up of nichrome, manganese and which one? Nichrome, manganese and constantan. Why? Because their resistivity or their resistance is almost independent of temperature. So even if temperature changes, their resistance remains same. And if we mix two metals and we prepare one alloy, if one alloy is made from two metals, then resistivity of alloy is greater than resistivity of each individual metal. Resistivity of alloy is greater than resistivity of individual metals. Then for semiconductor, graph between resistivity and temperature is like this. Temperature increases, resistivity decreases. This is true for germanium, silicon and carbon. For metals, this graph is like this. Initially graph is non-linear, but after some time after some temperature graph becomes linear. Then filament of bulb and heating devices, their resistivity should be high and their melting point should also be high. For fuse wire, resistivity should be high but melting point should be low. For fuse wire, safe current and radius of the wire. Safe current is proportional to radius raised to 3/2. Then for thermistor, alpha value should be high. Alpha value should be high.